Hey, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions to the Corbettmaths practice questions on congruent triangles. If you need any extra help on congruent triangles, if you go to Corbettmaths and go to the videos and worksheet section and scroll down to video number 67 and 328, there's dedicated video tutorials there on congruent triangles. Alternatively, you can scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. Okay, question number one. Question number one, we're told that ABC and LMN are congruent triangles. So these two triangles are congruent. And we're told that angle B is equal to angle N. And then if we go on down, we've been asked to write down, in part A, write down the length of MN. So we want to write down the length of MN. So if we have a look here, we've got this LN, and it's got a length of 15.5 centimeters. We've got the angle that we know is equal to this angle here. And then we're trying to find the length of MN, which is the side on the right-hand side there. So if we then have a look at this angle at B, which is equal to the angle at N, we've got the 15.5 on one side of that angle, but on the other side, we'd have this length here, which is 9.1 centimeters. So that means that MN would be 9.1 centimeters, because obviously the lengths of the sides on either side of the angles must be the same, because remember the condition, side, angle, side, side, angle, side, side, angle, side. Okay, so that means that MN is 9.1 centimeters, 9.1 centimeters. Okay, then part B, we've been asked to explain why angle A equals angle L. So we've been asked to explain why this angle here, I'm going to mark it there with a double arc like that, and it is equal to this angle here. So we're trying to explain why these two angles are equal to each other. Okay, so let's consider the conditions for congruent triangles. So we know that this angle, the angle at B, is equal to the angle at N. We've got the LN is equal to 15.5 centimeters, and we've got the AB is 15.5 centimeters, and then we've got the angle at A and also the angle at L. So remember the condition angle, side, angle. If you've got an angle, a side, and an angle, then they will be congruent triangles. So we've got an angle, a side, and an angle, a side, and an angle. So that's why they would be equal to each other. So let's explain that. And that's it. I've just explained that as AB equals LN, those two lengths are equal to each other, and angle B equals angle N, then angle A must be equal to angle L due to angle, side, angle, because we have the angle, the side, and the angle. The angle, the side, and the angle. And that's it. Now you may have considered other conditions, but that's one that I considered. Okay, let's look at our next question, question number two. Okay, so question number two, we've been given two congruent triangles, so we're told that these two triangles are congruent, and we've been asked to circle the reason why these two triangles are congruent. Okay, so if we have a look here, well, we've got the sides are labelled, the lengths of the sides, 8 centimeters, 9 centimeters, and 11 centimeters. And again, here we've got 8 centimeters, 9 centimeters, and 11 centimeters. So all three sides are equal to each other, so that'll be side, side, side. So side, side, side. We know it's not going to be this one because we've not been given any angles. Definitely not that one because we've not been given two angles. And it's not going to be right angle, hypotenuse, side because these aren't right angle triangles. So that's it. It's going to be side, side, side. Those two triangles are congruent to each other because the sides are all equal to each other. So therefore they must be congruent. Okay, let's look at our next question, question number three. Okay, so question number three says, shown below are two congruent triangles. So these two triangles are congruent to each other. And we've been asked to circle the reason why these two triangles are congruent. So let's have a look at them. We've got a 90-degree angle. We've got a side that has a length of 3.2 centimeters, and then an angle on the right-hand side of that side, which has a size of 63 degrees. And likewise up here, we've got our 3.2 centimeters, we've got our right angle, and we've got our 63-degree angle. Now, we've been asked to explain why these two triangles are congruent to each other. So let's consider these conditions. Right angle, well, yeah, there's a right angle. Hypotenuse, well, we've not been given the size of the hypotenuse, so it's not going to be that one. And side, I always think of this one linked in with Pythagoras' theorem, that if you've got a right angle and a hypotenuse and a side, that you could use Pythagoras' theorem to get the other side, so therefore it'd be side, side, side. In this one here, we don't have the hypotenuse, so it's not that condition. Side, angle, side, well, we've only been given one side, so it can't be that one. Angle, side, angle, we've got an angle, we've got a side, and then we've got an angle, a side, and then an angle. So it's going to be that condition, and it's not going to be side, 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 because we've not been given three sides. So that's it. Okay, let's look at our next question, question number four. Okay, so question number four, we've been asked for each pair, state the condition why they're congruent. So we've been asked to explain why these two triangles are congruent to each other. Well, we've got triangle A and triangle B. We've got a side, and we've got an angle, and we've got a side. We've got a side, an angle, and a side. So the condition will be side, angle, side. Okay, next, B. Okay, so on B, we've got two triangles. They're labelled C and D. And we've got a side, and another side. A side, and another side. So the condition will be side, side, side. So that's why those two triangles are congruent to each other. Okay, then C. So part C, we've been given two triangles, E and F, and let's have a look at them. So in E, we've got an angle, and a side. And in F, we've got the same angle, and the same side. So it's going to be angle, angle, side. So that's another condition, angle, angle, side. You may have worked out the missing angle here to be equal to 75 degrees, and this angle will be 75 degrees, and you can say, well, it's going to be angle, side, angle, but I'd probably have a look at this and just say, well, they've given us angle, angle, side, so that'll be the condition there. Okay, next, so question number 5, we've been given two congruent triangles, so we've got these two triangles, and they're congruent to each other, and we've been asked to circle the reason why these two triangles are congruent. So we've got a right angle, we've got a side, and then we've got the hypotenuse, which is another side. So we've got right angle, hypotenuse, side. So it's going to be right angle, hypotenuse, side. Because if you think about it, if you were to use Pythagoras' theorem, you could work out the length of this other side, and then they would be equal to each other because 10 is the hypotenuse in both of the triangles, shorter side in both of the triangles. So if you use Pythagoras' theorem, you get that side and that side to be equal to each other, and then you'd have side, side, side. But here we've got a right angle, a hypotenuse, and a side, and that's the condition we would use here. Okay, let's have a look at the next question, question number 6. So question number 6 says that James and Chris each draw a triangle with one side of 10 centimeters, one angle of 45 degrees, and another angle of 85 degrees. And James says their triangles are congruent. Explain why James is incorrect. Okay, so with a question like this, I'd sometimes like to do a little sketch. So I'm just going to do a little sketch here of what the triangles could look like. So let's just sketch this triangle so that we've got one angle of 85 degrees, another angle of 45 degrees, and then in terms of the side, well, I'm going to put the 10 centimeter side there. Now we could also have this triangle here where this is an 85 degree angle and that's a 45 degree angle, so the angles are in the same positions, but I could move the 10 centimeter line, I could move it from being this position to this position here. Now if we had this triangle here, this one would not be congruent to this triangle, because here we've got side, angle, angle, and here we've got angle, angle, side. The side's in a different position, so these would not be congruent triangles. If you were actually to work out the length of this side here, this side would be bigger than 10 centimeters, whereas this side here would actually be smaller than 10 centimeters, so they wouldn't be congruent to each other. So let's explain that. And that's it. I've just explained that we do not know the position of the 10 centimeter side in relation to the two angles, so therefore the two triangles above are not congruent, because here we've got the two angles here, and we've got the two angles here, but we don't know the position of the 10 centimeter line from what we've been told in this information. So that means that they aren't necessarily congruent. They could be congruent, there's the possibility they're congruent, but he says they are congruent. Well, he may not be correct because we don't know the position of that 10 centimeter line. Okay, let's look at our next question, question number 7. So question number 7 says, shown below are 6 triangles that are not drawn accurately. So we've got these 6 triangles, A, B, C, D, E, F, and then we're asked which two triangles are congruent to triangle A. So we want to find which two triangles are congruent to triangle A, so in other words, exactly the same as triangle A. So if we go up, triangle A has got a 71 degree angle, a 64 degree angle, and a side with length 4.6 centimeters. So let's have a look and see if we can find any other triangles that have got 71 degrees, then 64 degrees, and then 4.6 centimeters. Okay, so let's start off by saying if we can find any triangles that look exactly like this with the 71 degree angle, the 64 degree angle, and then the 4.6 centimeter length side. And then if need be, we'll then work out missing angles and so on if we have to. Okay, so triangle B, no, it doesn't have the 71 degree angle. Triangle C, it does have the 71 and the 64 and the 4.6. Let's have a look at the order. We've got 71 and then 6.4 and then 4.6. So yeah, triangle C would work. So that's going to be one of the congruent triangles. I'm going to write that down, triangle C. Okay, so I'm just going to give that one a tick because we've done that one. Okay, triangle D, it doesn't have the 71 degree angle. And then if we go on down, triangle E, it doesn't have the 64 degree angle, and triangle F doesn't have the 64 degree angle either. So we were just looking for the triangles that look like triangle A to begin with. And we found one triangle that was congruent to A already, which was triangle C, because we have angle, angle, side, 71, 64, and then 4.6. 71, 64, and then 4.6. Okay, now let's find the sides of the missing angles, okay? So I'm going to add together the 71 degrees and the 64 degrees, so 71 plus 64, and let's see what we get. 1 plus 4 is equal to 5, and 7 plus 6 is equal to 13, so that's 135 degrees. And then if we do 180 subtract 135, so subtract 135, that's equal to 45 degrees. So that means that this angle here is 45 degrees. Okay, so I'm now going to change the way I'm looking at this, because rather than looking at angle, angle, side, I'm now going to look at angle, side, angle. I'm going to look for 64 degrees, a 4.6 centimeter line, and then a 45 degrees, so angle, side, angle. Okay, and actually if we have a look here, triangle D, we've got the 45 degree angle, the 4.6 centimeters, and the 64-degree angle. Okay, it's a reflection, it's flipped around, but it's still congruent because it's angle side angle, 45, 4.6, and 64. 45, 4.6, and 64. So triangle D would be congruent to triangle A as well. So let's write that down, triangle D. Okay, let's have a look and see why we can rule out triangles B, E, and F. So in terms of this angle here, if you add together 45 and 64, you get that's equal to 109 degrees. And then if you take that away from 180, you get that's equal to 71 degrees. So that's 71 degrees. Now if we have a look here, the 4.6 centimeter line was in between the 64-degree angle and the 45-degree angle. Whereas in this triangle, it's in between the 71-degree angle and the 45-degree angle. So it's not in the right position. So that one wouldn't work. Then if we go on down, if we add together 71 and 45, that's equal to 116. And if you take that away from 180, you get that's equal to 64 degrees as well. And then if we have a look here, the 4.6 is in between the 71 and 45. But if we go back up, the 4.6 isn't in between the 71 and 45. It's in between the 64 and the 45, so to work for angle side angle. And then if we have a look at this one, if we add together these ones and then take away from 180, we get that's equal to 64 as well. And again, the 4.6 isn't in the right position for angle side angle. So that's it. So which two triangles are congruent to triangle A? They are C and D. Okay, let's look at our next question, question number 8. So question number 8 says, shown below 4 triangles. So we've got these 4 triangles, A, B, C, and D. And if we go on down, we've been asked to find which two triangles are congruent. So we want to find which two triangles are congruent. Okay, so if we have a look at them, we've got 15 and 20. 15 and 20, that's a 70-degree angle opposite the 15. That's a 60-degree angle opposite the 15. So I'm not sort of spotting that they're congruent to each other. Here we've got 50 degrees in the 15, so it might not be congruent to the others. Okay, let's have a look and see what this missing angle here is. So let's add together the 50 and 70-degree angles, and we get that's equal to 120. And then if we do 180 subtract 120, that's equal to 60 degrees. So that's a 60-degree angle there. And then actually if we have a look here, we have got angle side angle. We've got the 60-degree angle, the 15 centimeter line, and the 70-degree angle. The 60-degree angle, the 15 centimeter line, and the 70-degree angle. So triangles A and B are congruent because of angle side angle. So let's write that down. A and B. And that's it. Okay, let's look at our next question, question number 9. Okay, so question number 9. Question number 9 says, shown below are two triangles, PQS and QRS. And we've been asked to prove that triangle PQS and triangle QRS are congruent. So we want to prove that these two triangles are congruent to each other. Okay, so let's have a look here. Okay, well, the first thing I notice here is that we have got two angles, 65 degrees and 61. We've got the 61 and a 54. Let's find the size of this missing angle here and also the size of this missing angle here. So let's add together 54 and 61. So 54 plus 61 is equal to 4 plus 1 is equal to 5. And 5 plus 6 is equal to 11. So that's 115 degrees if you add them two together. And then if we do 180, take away 115 degrees, that's equal to 65 degrees. So this angle here is 65 degrees. Okay, that's great because the 65-degree angle here is the same as that one. Let's actually find the size of this angle here as well, just to see what that is. So if we do 65 degrees plus 61 degrees, that's equal to 126 degrees. And then 180 take away 126 is equal to 54 degrees. So that means that this angle here is 54 degrees. Okay, so this is great. We can now see that all three angles are the same in both triangles. Now that doesn't prove they're congruent to each other. It proves they're mathematically similar to each other, so they may be enlargements of each other. But also there's one other thing that I noticed here. I've also noticed that this side here, I'm just going to highlight it, this side here, QS, this side here, that side is shared. It's in both triangles. So that means that that side is in both triangles. Now because that side's in both triangles, we've actually got angle side angle. We've got an angle, we've got the side, and then we've got an angle. Both triangles have got a 61-degree angle, this side, and then a 54-degree angle. A 61-degree angle, that side, and a 54-degree angle. So that means they're congruent to each other due to angle, side, angle. We've got an angle, this shared side, and then an angle. That means they're congruent to each other. So let's write that down. Okay, so I've just started by writing that angle PSQ is 54 degrees, and also angle SQR is 54 degrees. So those two angles are both equal to 54 degrees, and I've just written that down. And remember, you've got your little angle symbol there, and you just list the three letters PSQ. SQ. And you just trace your finger or a pencil along those letters, and you start at P, you go to S, you go to Q, and you can see we're talking about this angle here. So that angle's 54 degrees and that angle's 54 degrees. Then I stated that angle PQS is equal to 61 degrees, and angle QSR is equal to 61 degrees as well. So those two angles are the same as each other. And then finally I've said that the side QS is shared, that this side is shared. So therefore, I'm going to then write down that they're congruent due to angle side angle. So therefore, those three dots mean therefore, triangle PQS and triangle QRS are congruent. I'm just moving up here to give myself a bit of room, due to angle side angle. Because we've got an angle, a side, and an angle, that means they're congruent to each other. Okay, let's look at our next question, question number 10. Okay, so question number 10 says, Oscar says that AAA, angle, 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 can be used to prove that two triangles are congruent. And Evan says that AAA, so that's angle, 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 can be used to prove that two triangles are similar. Who is correct, and explain your answer. Oh, so that's fantastic. If you think back to our last question, question number 9, I've actually just said that angle, angle, angle can be used to prove that two triangles are mathematically similar to each other. Think about if you had an equilateral triangle with a 60-degree angle, a 60-degree angle, and a 60-degree angle, and then a bigger equilateral triangle, they would also have 60-degree angles, that those angles will be the same, so that proves the triangles are mathematically similar to each other. Now, in theory, you could have the angle, angle, angle for one triangle, and another angle, angle, angle for another triangle, and those two triangles would be congruent, but there would also have to be a side that you know is equal as well, and say, well, okay, the side length for this one's 8 centimeters and the side length for that one's 8 centimeters as well. So I suppose then that would be an angle side angle and not an angle angle angle. So angle 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 proves that two triangles are similar to each other. So Evan's correct. Let's explain that. And that's it. I've just explained that Evan's correct. With three equal angles, the triangles would definitely be similar. And that's it. Okay, let's look at our next question, question number 11. So question number 11 says that ABCD is a parallelogram, and we've got this parallelogram ABCD, and you can see it's been split across here diagonally. Points B and D are joined up, and we've been asked to prove the triangles ABD and triangle BCD are congruent. So we want to prove that this triangle is congruent to this triangle. Okay, so let's look at this and see what we've got. So the first thing I notice here, if we look at triangle ABD, we've got the side BD. And if we look at triangle BCD, we also have the side BD. So BD is shared, so I'm going to write that down to begin with, that BD is shared. Okay, so that's fantastic. We now know the two triangles have a side in common, and that means it'll have the same length for both of those triangles. Now, if we also have a look here, we know we've got a parallelogram, and the opposite sides of a parallelogram have got the same length. So that means that AB would have the same length as CD. So it means that this side has got the same length as this side. So let's write that down. So just written down that the side AB and CD are the same length as each other, because we know the opposite sides of a parallelogram have the same length, or they are the same length. So that means that those two sides are the same length. So we know that BD is shared. We now know that AB and CD have got the same length. And also we've got AD and BC. Those two sides will have the same length as well, because the opposite sides of parallelogram have got the same length as each other. So that means that we know that AB is the same length as CD, we know that AD is the same length as BC, and we know that BD is shared. So that means the triangles have got three sides the same length as each other. This side's going to be shared, so it's the same in both triangles. This side's got the same length as that side, and that length's got the same length as that side. So it's going to be side, side, side. The two triangles are going to be congruent due to side, side, side. So let's finish this off. So let's write down that BC and AD have got the same length. And that's it. I've just written down that AD equals BC, as the opposite sides of a parallelogram have got the same length. And that means that triangle ABD and triangle BCD are congruent due to side, side, side. And that's it. Okay, let's have a look at our next question, question number 12. Okay, so question number 12. Question number 12, we're told that two triangles below are congruent. So two of these triangles are congruent, and we've got four triangles, A, B, C, and D. And we're told that two of them are congruent, and we've been asked to identify the two congruent triangles and to explain your answer. Okay, so we need to find the two congruent triangles and to explain our answer. Okay, so let's have a look at these. So they're all right angle triangles, that's great. So they've all got an angle in common, they've all got that 90-degree angle. And then we've got these three with a base of 9 centimeters. We've got C and B, we've got labeled 18 centimeters. With C, it's the hypotenuse, and with B, it's this other shorter side. So we can see straight away that B and C would not be congruent triangles, because if you use Pythagoras' theorem, you're going to find out that this length is less than 18 centimeters, whereas this length will be greater than 18 centimeters. So these two triangles are not congruent to each other. Okay, and then we've got these other triangles A and D, and this one's got a 30-degree angle, so that means that this one will be 60, so that'll be a 60-degree angle, and this angle up here, if that's 60, that'll be 30 as well. Okay, so let's find some of the lengths of the missing sides and also the missing angles. So let's use trigonometry and Pythagoras' theorem to work out the lengths of the missing sides. So let's start off with B and C and find the lengths of these two missing sides. So in terms of B, we're going to label the sides A, B, and C, and we're going to use Pythagoras' theorem that A squared plus B squared equals C squared. And here we've got that that's equal to 9, so 9 squared plus, and then B squared is 18 squared, and that's equal to C squared. And if we square them and add them together, let's see what we get. So 9 squared plus 18 squared is equal to 405, and that's equal to C squared. And then if we square root, we're going to get that that's equal to 9 root 5, or 20.124, and so on. Okay, so that means the length for this side here would be 20.124 and so on centimeters. So that's the length for the hypotenuse there. Let's have a look at C and work out the length of this missing side. So this is the hypotenuse, that's the longer side, so that's C. This would be A and this would be B. And then we'll use Pythagoras' theorem again, that A squared plus B squared equals C squared. So we've got 9 squared plus B squared equals C squared, which is 18 squared. So let's square that and get 81 plus B squared equals 324. And then if we take away 81 from both sides, we'll get that B squared equals 243. And then if we square root that, we're going to get an answer of 9 root 3, or 15.588, and so on. So that's 15.588 and so on centimeters. Okay, so that's fantastic. We've got the lengths of those sides. Now we could work out the sides of the angles as well inside of those triangles using trigonometry. But what I'm actually going to do is I'm going to work out the length of this hypotenuse and the length of this hypotenuse. And hopefully that'll help us find the triangles that are congruent to each other. So let's have a look at this one up here. We have got a right angle. The side opposite the right angle is called the hypotenuse. So let's label that H, and that's what we want to try and find. And if we're looking at this angle here, that's the opposite, and that would be the adjacent. In this question, we're not using and we're not trying to find the adjacent, so let's cross that off. And here we're going to be dealing with the opposite and the hypotenuse. And the trig ratio that deals with the opposite and the hypotenuse is the sine. The sine of theta, an angle, is equal to the opposite divided by the hypotenuse. Okay, so we want to find the hypotenuse here. So let's substitute in the values we know. We know that the angle is equal to 30 degrees, so it's going to be the sine of 30 degrees is equal to the opposite, which is 9, divided by the hypotenuse, which is what we're trying to find H. And then we want to solve this equation. So to solve this equation, we'll times both sides by H to get the hypotenuse times the sine of 30 is equal to 9. And then if we divide both sides by the sine of 30, we're going to get, and if we do 9 divided by the sine of 30 on our calculator, 9 divided by the sine of 30, that's equal to 18. So that means that this length, this hypotenuse, has got a length of 18 centimeters. Okay, so that's fantastic. We've now found the length of this hypotenuse, and that's equal to 18 centimeters. Now this is actually fantastic now, because I actually know that the two congruent triangles will be triangle A and triangle C. Because if we think to our conditions for the right angle triangle, one of the conditions is what we call right angle hypotenuse side, where they've got a right angle, yes. We know the lengths of the hypotenuses are the same, so we know that that's equal to 18 and that's equal to 18, so yes, they're the same as each other, so that's going to be hypotenuse. And then we've got side, and that's one of the two shorter sides are equal to each other, so that's 9 centimeters and that's 9 centimeters. So these two triangles are congruent to each other due to right angle hypotenuse side, and that's it. So let's write that down. The triangles that are congruent are A and C. And that's it. I've just said that A and C, triangles A and C, are congruent to each other due to RHS, right angle hypotenuse side, because they both have a right angle, a hypotenuse of 18 centimeters, and a shorter side of 9 centimeters. And then obviously if it's a right angle triangle and you know the hypotenuses are the same as each other and one of the shorter sides are equal to each other, you could use Pythagoras' theorem to find that the other side would be equal to each other, so it'd be side, side, side. But because we already know it's a right angle triangle and we know the hypotenuse and we know that this shorter side is the same for both triangles, we can actually skip out the Pythagoras' theorem and just say they're congruent due to RHS, right angle hypotenuse side. Okay, let's look at our next question, question number 13. Okay, question number 13. So question number 13, we've been given a rhombus, DEFG, and we're told the diagonals intersect at the point H here. And we've been asked to prove that triangles DGH and EFH are congruent. So DGH, that's this triangle here. I'm just going to highlight it here. So that's triangle DGH and triangle EFH. So EFH, like so. So that triangle there. So we want to prove that these two triangles are congruent. Okay, so let's do that. Okay, so we want to prove that this triangle is congruent to this triangle. There's a few different ways we could do this. One approach is to consider side, side, side. The fact that we've got DG, so that's one side of a rhombus. Now remember, a rhombus is a pushed over square, so all four sides have got the same length as each other. That this side would have the same length as this side. So we could write that down, that DG equals EF. Okay, so we've said that DG equals EF as the sides of a rhombus have the same length. And then also we've got two diagonals of a rhombus. Now two diagonals of a rhombus, this diagonal DF and this diagonal EG, they will cross each other at 90 degrees, but also they'll bisect each other. So that means that this length will be the same as this length, and that means that this length will be the same as that length. So let's write that down. So that means that EH would be equal to HG because it bisects that line, EG, but also that DH equals FH as the diagonals of a rhombus bisect each other. So that means that this diagonal's been cut in half, and that means that this length, DH, would be the same as this length here, FH, but also that this diagonal's been cut in half, and that HG would be the same length as EH. So that means if we have a look at these triangles, we know that DG would have the same length as EF, because we know the sides of a rhombus have got the same length. We know that GH would have the same length as EH, and we'd also know that DH is the same length as FH. So that means that these two triangles are congruent due to side, side, side. So let's explain that. And that's it. I've just explained that triangle DGH and triangle EFH are congruent due to side, side, side. Now there's other ways you could do this. You could actually use the fact that it's a pushed over rhombus and the fact that this line is parallel to this line to show that some of the angles are equal to each other. So you could say that this angle here will be the same as this angle here, because if we've got two parallel lines, we've got that alternate angle, that Z angle there. So it means that these two angles would be equal to each other. But also these angles here, this angle and this angle will be equal to each other because they're alternate as well. And then we know that this side has the same length as that side, because remember that the sides of a rhombus have got the same lengths. So that would be angle, side, angle. So you could prove it that way as well. You could even look at vertically opposite angles. If you get two lines that cross each other, this angle will be the same as that angle, and so on. So there's lots of different ways you could prove it, but I've used side, side, side. Okay, let's look at our next question, question number 14. So question number 14, we're told that the lines CE and DF intersect at this point G, and we're told that CD and FE are parallel, and that CD and FE have got the same length as each other. And we've been asked to prove the triangle CDG and triangle EFG are congruent. So we want to prove that this triangle is congruent to this triangle. Okay, now first of all I'm going to start off with the fact that CD equals FE. So this side here has got the same length as this side here, because we're told that CD equals FE, and that's been given to us. So that's been given. Okay. Now we want to prove these triangles are congruent to each other. I'm actually going to consider some angles here because I'm thinking back to angles and parallel lines. We know that CD is parallel to EF or FE. So that means that we may have some alternate angles here. So if we have a look here, consider now, remember our Z angles, those alternate angles. This angle here would be the same as this angle here. And I'm just going to highlight those, that this angle here would be the same as this angle here. The reason is that they are alternate angles, that if you've got two parallel lines, if you've got that transversal, the angle here would be equal to the angle here. So angle DCG equals angle GEF as alternate angles are equal. Alternate angles are equal. Okay, so that's fantastic. We now know that both triangles have got a side that's got the same length, and they've both got one equal angle. Now we've also got another pair of alternate angles. This angle here will be the same as this angle here. And again, remember, we've got our two parallel lines, we've got the transversal, so those two angles would be equal to each other. So they would be equal to each other as well. So let's write that down, that angle CDG equals angle GFE, as again alternate angles are equal. So that's fantastic. We now know that both triangles have got an angle, a side, and an angle that are all equal to each other. So that means they're congruent due to angle, side, angle. So let's explain that. And that's it. I've just explained that triangle CDG is congruent to triangle EFG due to angle, side, angle. And that's it. Okay, let's look at our next question, question number 15. Okay, question number 15. Question number 15, we're told that triangle DEF is an equilateral triangle, and the point G lies on EF, and that DG is perpendicular to FE. So in other words, they meet at 90 degrees, like so. And we've been asked to prove the triangle DFG is congruent to triangle DEG. So we want to prove that these two triangles are congruent to each other. Okay, so the first thing I notice here is that this side here, DG, is shared. This DG is in both triangles. So let's write that down, that DG is shared. So whenever I'm dealing with these congruent triangle questions, if I can spot any shared lengths, that can be quite useful. Okay, so DG is shared. Okay, now what I also notice here is that we have got DF and DE. Now it was an equilateral triangle, so that means that this length is the same as this length, because we know that with an equilateral triangle, all three sides have got the same length as each other. So that means that DE equals DF as triangle DEF was equilateral. Okay, so that's fantastic. We now know that DG is shared. We know that DF equals DE. Okay, now there's a few different ways we could finish off this question. One approach now is to say, well, if that's 90 degrees, that this would be 90 degrees as well. That angle DGF equals angle DGE as both are 90 degrees. And then what you could actually say is that due to right angle hypotenuse side, because we've got both triangles have got a right angle, we know that both of the hypotenuses are the same length, and we know that the shorter side, DG, would be the same length from both of them, that due to right angle hypotenuse side, that these two triangles are congruent to each other. So that's one way you could do this question. Another approach is actually to say, well, this would be a 60-degree angle, because remember it was an equilateral triangle, and so would this one. And then because these are right angles, that means that this angle up here would be 30 degrees, and that angle would be 30 degrees. And then at this point, you could say due to side angle side, so side angle side, that they're congruent. So that's another way you could finish off this question. You could even say due to angle side angle, so this angle, this side, and this angle, this angle, this side, and this angle, and so on. So there's quite a few different ways. But I'm going to use the right angle hypotenuse side one because that's the first one that I noticed. So let's write that down. And that's it. I've just written down that triangle DFG is congruent to triangle DEG due to right angle hypotenuse side. And that's it. So question number 16 says ABC is an isosceles triangle in which AC is equal to BC. And then we're told that D and E are points on BC and AC such that CE equals CD. And then we've been asked to prove the triangles ACD, so that's triangle ACD. I'm just going to highlight that just so we can see it more clearly. ACD. So we've been asked to prove that that triangle ACD, so triangle BCE. So we've been asked to prove that those two triangles are congruent to each other. Okay, so let's write down what we know so far. Okay, so the first thing that I noticed is that we were told that the original triangle ABC was an isosceles triangle. And we've got the AC and BC are included in the triangles that we're looking at, but we know that those two sides are the same length. Because it's an isosceles triangle, we were told that AC equaled BC, so we know that those two sides are equal to each other. So let's write that down. AC equals BC, as they're equal sides of an isosceles triangle. Okay, so that's the first thing that I've written down there. Okay, now another thing that grabs my attention is if we have a look at this angle here, down here, this angle is in both triangles. It's in the triangle BCE, so it's in that triangle there, but it's also in the triangle ACD. So this angle here is shared. So let's write that down. The angle ACB is shared. And then we were also told in the question that D and E are points on BC and AC such that CE equals CD. So we're told that this length here, from here to here, is equal to this length. So we know that CE equals CD, and that was given to us as given. So if we have a look here, let's have a look at each triangle individually. So I'm just going to rub these out again. So if we have... So I'm just going to rub those out and let's look at each triangle. Okay, so let's start off with triangle ACD. So we know that AC is the same as BC. So we've got this side is the same as one of the other sides. We had that CD is equal to CE. So that side was the same as the other one. And then we also had the angle in between them is shared. And then if we have a look at that other triangle, so that triangle there, we've also got that side was congruent to this side. We had that this side here was congruent to that side there. And then we had that shared angle. So angle, side, angle. So those two triangles are congruent due to angle, side, angle. So let's write that down. So we've got that side, that angle, and that side. So we've got that side, angle, side, that SAS. So we know those two triangles are congruent. So let's write that down. So ACD is congruent to BCE due to side, angle, side. So side, angle, side. And that's it. Okay, let's have a look at our next question, question number 17. So question number 17 says the diagram shows triangles ABC, so ABC, and triangle ADG. And we're told that the lines DG and BC are parallel, so this line's parallel to that line. We're then told that DF, so DF, that line there from D to F, is equal to EG, and we're also told that AB equals AC. And we've been asked to prove the triangle ADE, so triangle ADE, this triangle here, is congruent to triangle AFG, so AFG there. So we want to prove that this triangle is congruent to that triangle. Okay, so let's start off with this information. So we're told that the lines DG and BC are parallel. Okay, so we might come back to that in a moment. I'm just going to have a look at this part next, that DF equals EG. So DF equals EG. Okay, so let's have a look at that. So DF, so if we have a look there at DF, that's equal to DE plus EF. So that's equal to DE plus EF. So that distance from D to F would be equal to DE plus EF. So that distance plus that distance equals that distance. Well, that makes sense. And also we're told that the DF, and that's equal to EG. So let's have a look at EG now. So EG would be equal to EF plus FG. So EF plus FG. Now, if we have a look at that, both of those, DF and EG, they both have EF in common. You've got EF there and EF there, because obviously there to there would be that distance plus that distance, but also from E to G would be that distance plus that distance. So EF is in both of those. So that means that obviously because these two are equal to each other, that means that DE equals FG. So DE equals FG. So that distance there would be equal to that distance there, because obviously if we know from here to here is the same as from here to here, and they both have that in common, that means that that distance would be the same as that distance. Okay, so we've got that to begin with, and both of those are sides in those two triangles that we're interested in. Okay, now if we carry on, we're then told that AB equals AC. So AB equals AC. That means that triangle ABC must be an isosceles triangle. I suppose it could be an equilateral triangle, but we're not told that it equals BC. But we know then it must be an isosceles triangle because we know that AB equals AC. So that means that that distance is the same as that one. And also we know that the lines DG and BC are parallel to each other. So those are parallel lines. That means that triangle AEF and triangle ABC must be mathematically similar because they've got an angle in common, that angle BAC, and also you've got those two parallel lines. So think back to similar shapes. So that means that triangle ABC must be mathematically similar to triangle AEF. And why that's interesting is because obviously if we know that AB is equal to AC, it must mean that AE would also be equal to AF. It must mean that if the big triangle is an isosceles triangle, the little triangle will be isosceles as well, because they're enlargements of each other. So let's write that down. Okay, so I've written down quite a lot there. So I've started off by saying that since AB equals AC, the triangle ABC is an isosceles triangle. And then as EF and BC are parallel, that means the triangle AEF and ABC are similar. So that means that triangle AEF would be isosceles as well. So therefore we can conclude that AE must be equal to AF. So let's write that as well. Okay, and I'm just going to shorten the diagram there with a little dash there, with two little dashes there and two little dashes there. Okay, so we've now got that the two triangles we're interested in, ADE and triangle AFG, that we know that this side is the same length as that side, and we know that this length is the same as that length. Okay, so we just need to do one more thing. We either need to show that AD is equal to AG, or we need to find an angle, perhaps this angle here, so this angle AED, and see if that's the same as AFG. And then, so let's do that. Let's have a look at the angles. Okay, so we weren't actually told any angles in the question, so I'm going to let this angle here be X. And that means that that angle there would be X as well, because we know that that's an isosceles triangle with AB equals AC. Okay, so if this angle is equal to X, this angle is equal to X, so it's an isosceles triangle. Now we know we've got some parallel lines. We know that DG is parallel to BC. So that means we've got some corresponding angles. If you've got this transversal that crosses the two parallel lines, we would know that that angle there is corresponding to that angle there. Those two angles are corresponding angles. If you were to carry on the transversal and carry on the parallel line, you see it's the top right angle and the top right angle. So that means that that's X as well. And likewise, this is an isosceles triangle, so this must be X as well. Or remember, this angle is corresponding to this one. Okay, so that's fantastic. Actually, let's write this down. Okay, so I started off by letting angle ABC equal X. So that was my first step. And then we knew that angle ACB would be equal to X as well, because it's an isosceles triangle. So let's write that down. Okay, so that was our first step. And then we knew that these angles here were also equal to X because they're corresponding to the angles below those. So let's write that down. Okay, so then I've written down that angle AEF equals angle AFG, and they're both equal to x as well, as they're corresponding to angles ABC and ACB. Okay, now let's actually then find what this angle here would be. So here, this is a straight line, DG is a straight line. So if we take x away from 180 degrees, that means that this angle here would be 180 subtract x. So for instance, if this was 10 degrees, that would be 170 degrees and so on. So this is 180 minus x degrees. And likewise, remember that DG is a straight line, so that means that this angle here would also be equal to 180 degrees minus x. So just considering the angles in a straight line, that this angle and this angle must add together to be 180 degrees. And likewise, this angle and this angle must add together to be 180 degrees. So this is fantastic. We've now got a side, an angle, and a side. So it'd be side, angle, side. But let's go back and write down why angle AED is equal to 180 minus x, and likewise angle AFG. Okay, so I've just written down that angle AED equals angle AFG equals 180 minus x, because the angles in a straight line add together to be 180 degrees. And then finally, let's write down that those two triangles, triangle ADE and AFG, are congruent due to side, angle, side. So let's write that. And that's it. I've just written down that triangle ADE is congruent to triangle AFG due to side, angle, side. And that's it. Okay, and let's have a look at our last question, question number 18. Okay, so question number 18, we're told that ABCD, so ABCD and LMNO are squares. So we've got a big square and then this smaller square. And angle CBL, so CBL is equal to x degrees. And then if we go on down, we've been asked to prove the triangle ABO, so this triangle here, and triangle CBL, so CBL, this triangle, so these two triangles here and here, are congruent. Okay, so let's have a look at this. Okay, now I'm actually going to consider the fact that LMNO is a square to begin with, because if that's a square, that means that that's a right angle, and that's a right angle, and that's a right angle, and that's a right angle. Okay, just labeling in those right angles for that smaller square. And likewise, AN is a straight line, so that means that that's a right angle there as well. And because OB is a straight line as well, that means that that's a right angle, because remember the angles in a straight line add together to be 180 degrees. So if it's a right angle there, that's a right angle as well. So if we now have a look at those two triangles, we now know that both of them have got right angles. So that's a good start. I'm just going to write all that down. It's important in these questions, these proof questions, that you write down your steps. Okay, so I've just started by writing down that angle BLC equals angle AOB, and they're both equal to 90 degrees because LMNO is a square. Okay, that's our first step. Okay, now let's have a look at this triangle CBL. So CBL, we know that's a right angle. We know that's equal to x. Let's find the size of this missing angle here. So remember, the angles in a triangle add together to be 180 degrees. So if we do 180 degrees, take away the 90 to begin with, that's equal to 90 degrees. That means that the other two angles, if this is the right angle, the other two angles must add together to be 90 degrees. But if this one's x, you take that away from 90. So that means that this angle here would be equal to 90 minus x degrees. So for instance, if that's a right angle and that's 80 degrees, that must be 10 degrees. 90 minus 80 would be equal to 10. So that means that this angle here is equal to 90 minus x degrees. So let's write that down. Okay, so I've just written down that angle LCB, so LCB, this angle here, is equal to 90 minus x degrees, as the angles in a triangle add to 180 degrees, so what we've used. Okay, so now if we have a look at this triangle, triangle CBL, we've got the size of the three angles. Let's have a look at triangle ABO and see if we can find the size of these two angles up here. Because at least then we'll have angle, angle, angle. That means they're mathematically similar for a start, and then we'll see if we can get any sides that are the same as well. Okay, so let's have a look at this right angle up here. Remember that ABCD is a square. So if this is equal to x degrees, this angle up here would be equal to 90 minus x degrees, because these two angles must add together to be 90 degrees. So to find the size of this one, you just take this one away from 90. So let's write that down, that angle ABO equals 90 minus x degrees. Okay, so I've just written down that angle ABO equals 90 minus x degrees, as the angles in a right angle add to 90 degrees. That's fantastic. And then finally, let's find the sides of this angle. So remember again that the angles in a triangle add together to be 180 degrees. Well, if this one's a right angle, that means the other two must add together to be 90 degrees. So if this is 90 minus x, this one here must be equal to x degrees, because these two must add together to be 90. Or you could just take the 180, take away 90, that's equal to 90. Take away 90 minus x, well, 90 take away 90 is equal to 0, but then we've got minus minus x, and that would be equal to x. But I think an easier way would just be, well, we need these two to add together to be 90 degrees, so this one here must be equal to x. So let's write that down. The angle OAB equals x degrees. Okay, so that's fantastic. Okay, so we've now got our two triangles and we've got the three angles are the same in both of those two triangles. We've got that this angle is x degrees, this angle is 90 minus x degrees, and this one is a right angle. And likewise here we've got the right angle, x, and 90 minus x degrees. So that means that the triangles must be mathematically similar. But also remember that ABCD is a square. So that means that the length of this side here, AB, must be the same as this length here, which is the side BC. So that means that this side is equal to that side. So that means that these two triangles must be congruent due to angle, side, angle. We've got our x degrees, that side of the square, and 90 minus x degrees. And likewise here we've got our x degrees, that side of the square, which is the same as that one, and our 90 minus x degrees. So that means that these two triangles, triangle ABO and triangle CBL, must be congruent due to angle, side, angle. And let's write that down. And that's it. I've just written down that AB equals BC. So the length of those two sides, AB and BC, are equal to each other because ABCD is a square. So the lengths of those sides must be the same. And that means that triangle ABO and triangle CBL are congruent due to angle, side, angle. And that's it. And that's it. So these have been the video solutions to the Corbettmaths Practice Questions on Congruent Triangles. If you need any extra help on Congruent Triangles, go to Corbettmaths and go to the Videos and Worksheets section and scroll down to video number 67 or 328, and there's dedicated video tutorials there on Congruent Triangles. Alternatively, you can scan this QR code. But in this video, we focused on the video solutions to the practice questions. I really hope you found this video useful. If you have found it useful, please like it and please subscribe to my YouTube channel. Also, if you know anyone else that might find the Corbettmaths resources useful, perhaps a friend, a relative, a teacher, anyone at all, please feel free to share the resources with them as well, and that might be useful for them and might help them with their maths as well. So thanks very much for watching this, and thank you. Cheers. Bye.